This lesson demonstrates animation using an image from a file and using a switch and case statement to dynamically modify how the animation proceeds. This is the doomed vessel class, which is a frame class that loads and displays the doomed vessel canvas class. One thing that's slightly different from the previous examples is the fact that we don't bother to store the component in a reference before adding it to the window. The new statement is used directly inside the add method. This works fine except in cases where you need to call a method of the component before adding it to the window. A state value is initialized to 0. Now this could have been done just as well in the declarations, but sometimes it just feels better to do it in the constructor. Two image objects are needed for this program. The first one is the working image that we'll use to draw animation frames, and the second holds the picture of the sailboat that will move across the window. Once again, we call on the image loader class that we developed earlier to load the image of the sailboat file and create an image object containing it. To do the actual animation, a thread is created and started running. Notice that the sleep method has a variable named pause that determines the sleep length. That's because we're going to vary it during the running of the program. Here, just like we've done before, we check for a change in size of the window and create a new image and rectangle object if the size has changed. The switch statement is based on the variable named state. In the constructor, its value was initialized to 0, so this block of code will be executed first for case 0. It sets the value of x and y, so the sailboat is positioned out of the window. It's actually off stage to your left. The pause value is set to 5,000, so the next sleep will be for a full 5 seconds, and the value of state is set to 1, so the next time through here, the next case will be executed. Now here's what's going to happen. First, the sailboat will be drawn out of sight to the left of the window. Second, the sleep method will halt the thread for a full 5 seconds. Third, the sleep method wakes up, calls repaint, which causes another call to update, which will cause the code in case 1 to be the one that executes. In this state, the boat is underway. The pause time is set to 33 milliseconds, which we've seen is a pretty fair animation time, and the location of the sailboat is shifted 1 pixel to the right. This will happen again and again, with the sailboat being drawn in each position until the value of x reaches halfway across the window. Once that happens, the state value is set to 2, so the next time through here, this code will execute. Here, the pause is set to 150, which will slow down the action some, and now it's the y value that's adjusted. The boat no longer moves horizontally, but starts moving slowly in a vertical direction, downward. This state of affairs continues until the boat is completely out of sight below the bottom of the window. At this point, the state is set to 0, and the whole process starts over again. The boat is positioned out of sight left. The sleep time is set to 5 seconds. The next state value is set to 1 to sail the doomed vessel back into treacherous waters. All the paint method does is fill the background and then draw the boat on it in the prescribed position. At first, there's nothing, as we would expect, because there is a 5-second delay. Then the boat comes out of hiding. You know, public domain images with stuff like this are hard to find, so I drew this one myself. I've already told you that I don't have any taste, but this proves now that I don't have any artistic talent either. The boat has reached the midpoint of the program and switches from state 1 to state 2, and down she goes. Once down there, we pop it back up to state 0 and encounter another 5-second wait, and here she comes again. Oh, this image, by the way, is a GIF and has some transparent pixels defined in it. That's why you can see the background colors through what is otherwise a square image. Oh, and watch this. The boat doesn't adjust to the new position of the bottom of the window because we only calculate the value of y in case 0. However, in case 2, the boat is sinking, and we continue to sink it until the bottom of the actual window is found. Now, when the boat starts over, everything has adjusted itself to the new window size because we've gone back through state 0. One way to fix this would be to reset the state to 0 every time the window changes size.